In this project, we're comparing two different algorithms and their runtimes and functionality for the closest points problem. The two algorithms we are comparing are the brute force algorithm and the divide and conquer algorithm. The brute force algorithm works in a way where it checks the distance between every possible point and chooses the closest pair. So it has a large runtime and which is n squared. And then there's the divide and conquer method, which sorts by the x coordinate and then splits the inputs in half and solves recursively by checking closest pairs on the upper and lower bound of the split. And the runtime for that is n log n. And then here we have the inputs, which are just random inputs up to 1,000,000 for x and y. And when we call it, we're doing going over it 10 times and averaging that. And for the input size, we're going up to 5,500 in iterations of 1,000. This is where we measure the time of the algorithms. Here's algorithm 1, algorithm 2, and then here are the calculations for the table to get empirical runtime, the ratio, which is empirical runtime divided by theoretical runtime, and then we can predict runtime from those calculations. As you can see, the brute force has very high runtime, and the predictions were right on, which means it's implemented well. And then for divide and conquer, much smaller runtimes. Also a pretty good fit with the predicted runtime, so could be mean we implemented it well. And then we have the runtime comparison. As you can see, brute force exponentially grows, whereas divide and conquer, it stays steady on a linear growth pattern, which is good for runtime. For brute force, we can see that it was a good fit for the predicted runtime, which means we implemented it correctly. And for divide and conquer, you can see the prediction was a little over the runtime, so the algorithm ran better than expected.